Okay, this is one of my favorite questions. It really gets you thinking. It's a half-life question, right? So I'm kind of borrowing this from MathXL right now. Complete the table shown to the right for the half-life of a certain radioactive substance. Now, this depends on a few things. Number one, we've talked about this in a previous video. Half-life. Half-life is a unit of time. Okay, so think about like half-life like you would a year, right? A year is 365 days. If I say 1 year, that is 365 days. But that's the way that it is on planet Earth, right? Okay, a year on Mars is different. A year on Neptune is different, right? So half-life is a unit of time similar to that, but it's different for every radioactive substance. Okay, so this is a unit of time. So when they say complete the table shown for the half-life and I don't know what the half-life is, that means I'm solving a setup here for T. And half-life models exponential decay. And this is our formula, quote unquote, or model for exponential decay. Now, they've given me the decay rate, 5.7% per year. It's negative. If you're wondering why it's negative, watch the previous video on half-life. Okay, but this is our value of K. Now, when we plug that number into this formula, okay, let's say negative 0.057, and I have to solve for T, okay, we did this in a previous problem. We did that in this problem, but we were solving for K. The difference in this problem is that I knew this and I knew this, right? And I just had to solve for that one variable. In this problem, I don't know how much I'm starting with and I don't know how much I'm ending with. But again, this problem can still be solved. There aren't 3 variables in this problem, okay? Because if we understand the concept of half-life, we're trying to find the amount of time. Don't get me wrong, we're solving for T, okay? But we're solving for T as a time that it takes for however much I started with to decrease by 50%. Which means instead of using A as this ending amount, I can say half of A naught. This is how much I start with, no matter how much I start with. If I start with 5, this would be 2.5. If I start with 10, this would be 5. If I start with 1,000,000, this would be 500,000, right? The half-life is the time it takes for however much I start with to decrease by half. All right. So I can express this amount as half of what I started with. Now, when we look at this, and I'm going to keep comparing it to the problem that we did here, right? We were solving for K in this model, in this problem. Here we're solving for T, but it's still in the exponential level, right? What did I do first in this problem? I isolated the power by dividing by 200. So I'll divide this by 200, right, on both sides. I had to get rid of that number that's in front. Now it's not a number, it's A naught. So I'm going to divide this side by A naught. And if I can express the left side in terms of A naught, and then I divide by A naught, those are going to cancel. And I'm going to have 1/2 equals E to the negative 0.057 T. And now I do only have one variable. Okay, so even though the prospects of this problem started poorly, once I was able to express this unknown in terms of a variable that was already in the problem, I got rid of, one of my variables. So now I'm here, okay, and I'm solving for T. To solve for T, I need to get it on the base level, so I log both sides. And after I log both sides, I've got the natural log of 1/2 equals, this number is going to come down in front, times the natural log of E. We've talked about the natural log of E before, right? This number is equal to 1. So essentially, I'm multiplying this product by 1. So I have the natural log of 1/2 equals negative 0.057 T. And the fact that the decimal's been introduced into this problem, I could probably write this as a decimal if I wanted to at this point. But I'm just going to keep rolling because this is a little bit cleaner. And if I'm solving for T, I'm going to divide by this number. Right? So it's solving for t the same way I solved for k in the previous problem. I'm not going to express my answer with a decimal. Oops, not a t, right? That's a 7. I'm not going to express this as my final answer. I'm going to go to Desmos and type this number in and get my answer from that. Okay. So we have the natural log of 0.5 divided by negative 0.057. So approximately 12.16 years. Approximately 12.16 years. Okay, so again, the crux of this problem, first of all, is recognizing that we're solving for a t, even though we don't know how much we start with, because we're talking about half-life, we have half of what we start with after this period of time. And then we divide by that and it goes away, and then we've only got one variable to solve for.